In this video, I'd like to talk about the features of a circle from its graph. So in these problems, we'll be given a circle and need to determine what the center of the circle is and what its radius is. So remember the definition of a circle, that it's the set of all points that is the same distance from some center. And we call that distance the radius of the circle. Now, with figuring out the center, it can be a little bit challenging. You might be able to visually see that it's somewhere in there. But one strategy is to determine the highest point on the graph and what its x value is. So that looks to be right about there with an x value of 3. And we can also determine the point on the graph that is either to the most right or the most left and figure out what its y value is. So that looks to be about this point here, and that has a y value of -1. Notice we can do the same thing on the left and the bottom. The leftmost point looks to be about right there, and the bottommost point looks to be about right there. Now notice that the x value of the top and bottom point is at 3, and the y value of the left and rightmost points is at -1. So our center then is a combination of that x and that y value. It will be at 3 minus 1. And we can test this by looking at the distance between the center to each of these points and making sure that it's the same distance, since that's the defining feature of the radius. It's the same distance to any point on the edge of the circle from that center point. And we can count. You can see there are 6 and then a little bit, maybe almost 6.5, not quite. And likewise, this goes up 6 and then that little bit. And you can see the same for the leftmost and the bottommost. So it does make sense based on that test. Now we're also told that the circle passes through at -1, -6. So we can plot that point at -1, -6. That's right here. And we want to know the distance between that point and the center of the circle. And if we can find that distance, then we know the radius of the circle. And we know it's roughly going to be 6.3 or 6.4, maybe somewhere around there. But with this method, we can find an exact answer. And to find this distance, there are two approaches we can take. Since now we know the center of the circle, that's at an x value of 3 and a y value of -1, and we know this coordinate point is -1, -6, we can use the distance formula, or we can construct a triangle and use the Pythagorean theorem, since the distance formula just comes from the Pythagorean theorem. So let's construct that triangle, and we need to find the legs. This is a right triangle, and once we find the legs, we can find the hypotenuse by using the Pythagorean theorem, the relationship between these three side lengths. So let's call this distance r for the radius, and notice that we're at a y value of -1 and we go down to -6. So that's a difference of 5 units. So this triangle is 5 units tall, and the base of the triangle, we could count that it's 4, or you can notice that it goes from -1 to 3, and if we find that difference, 3 minus -1, that would also equal 4. So we have this right triangle where the legs are 4 and 5, and the radius is r. So let's use our Pythagorean theorem. A squared plus b squared is equal to c squared, where a and b are the legs, and c is the hypotenuse. So plugging those in, we get 4 squared plus 5 squared is equal to r squared. And 4 squared is just 16. 5 squared, 5 times 5 is 25. And adding those together, we get 41. And to solve for r, we take a square root of each side. So the square root of 41 is equal to our radius. And you can see that this makes sense, because if you compare it to known square roots, like the square root of 36 and the square root of 49, you can see that root 41 is between 6, and 7. So it makes sense by what we counted here, or you can also plug this into a calculator to find the decimal answer, which is 6.403, and it goes on forever. And this does look to be about 6.4. So it makes sense visually, but this method here of knowing a point and the center can find the exact value for this radius.